Hi guys, this is Mrs. Ullrey, and in this video you're going to learn about states of matter, particle models, and density. So let's begin. So matter is anything that takes up space and has mass. Matter is made of particles. Matter can be represented using particle models. So down below here, this is a particle model. Each of these dots represents a particle of matter. So the dots are particles. The arrows represent movement. The longer the arrow, the faster the particle is moving. The shorter the arrow, the slower that particle is moving. So what we're going to look at is particle speeds as it relates to solid, liquids, and gases. So there's a link to a PhET that you guys can play around with. But what you should have noticed is that the slowest speeds are going to be the particles in the solid, followed by liquid, and then the fastest particles are going to be the particles in gas. And then in terms of distance between particles, solid particles are going to be closest together, liquid is going to be in between, and gas, those particles are going to be the furthest apart. So the other thing that you want to play with this PhET is you want to look at the effects of heat. So as heat is added to the matter, the particles move faster and they start to spread apart. As heat is removed, you should see that the particles start to move more slowly and then they come closer together. So down below we have 3 particle models, and this has the luxury of showing movement. So there's no arrows on here because the particles are actually moving. But our first model, that's going to be a solid. We can see that it has a perfect shape. All those particles are close together and they're moving the slowest. The middle is going to be our liquid, and then gas is going to be our last, where we can see the particles are moving more quickly and they're furthest apart. So here's basically some properties of each for solid, liquid, and gas being compared. So definite mass, so solid has a definite mass, liquid has a definite mass, and so does a gas, meaning that there's a certain amount of matter that they are made of. In terms of definite shape, solids have a definite shape. You see that with the desk that you're sitting at. That thing is solid and it has a definite shape. A liquid does not have a definite shape. You can see that with your water bottle as you see the liquid sloshing around inside. And then gases do not have a definite shape either. So the gas is going to take up whatever space we see in the room. So solids have definite volume, liquids have definite volume, but gases do not. And we can see this where we can take a room full of oxygen and cram it into a little space like an oxygen tank that you would use for scuba diving. Compressibility, solids are not compressible, meaning when you push down on them, they're not changing shape. Liquids, again, they're not compressible. We can't make 20 liters of water fit into a smaller space than 20 liters. But gases, yes, those are compressible. We can take 20 liters of gas and we could shrink that down into a 1-liter bottle if we wanted. Fluidity is just a fancy word for does it flow? Solids don't flow. You can't pour a solid, but you can liquids and you can with gases. Rigidity is the opposite of fluidity. So rigidity means are things stiff and solid. So solids, yep, are definitely rigid, and liquids and gases are not. Diffusion, that means can we pour it from one space to the other? Solids, if you let it sit for a really long time, some solids actually will diffuse, but liquids and gases, they diffuse between spaces very quickly. Spaces between particles, as we talked about already. Solids, those particles are really closely packed. Liquids, they're less packed, and then gases, they're really spread out. In terms of attraction between particles, how much the particles like one another, solids, very strong attraction, which is why they stick together and pack so closely. Whereas gases, there's almost no attraction between the particles, which is why they're so spread out. So density is the next thing that we're going to talk about. So this describes how closely packed the particles are in a sample of matter. The closer the particles are packed together, the more dense the substance. The further the particles, the less dense the substance. So if we take a look, do a quick learning check, pause the video and see for yourself, is substance A or B more dense? So which one is more dense? Pause the video and then check your answer. Okay, hopefully you took my word for it and you paused the video and you chose substance A. So we can see we have more dots, meaning more particles of matter in substance A than we do in substance B. And so because these particles are much more closely packed together, we would say substance A is more dense. And because these particles are more spread out, we're going to say that substance B is less dense. So we're going to actually do an experiment here with Coke and Diet Coke. And so objects that are more dense are going to sink, while objects that are less dense are going to float. So we're going to watch this video about Coke and Diet Coke. So we have our Coke and Diet Coke. We put the Coke in, and it sinks to the bottom. We put in our Diet Coke, and we can see that it's floating. Okay, so our observation is regular Coke sank, while Diet Coke floated. So now we're going to make some conclusions about the density of Coke versus Diet Coke. So here are 3 particle models, and so we have the densest particles over here, we have the least dense particles over here. So which one of these would represent Coke, which one would represent water, and which one would represent Diet Coke? So pause the video and make your conclusion. Okay, so hopefully, because you notice that the Coke sank in the water, that's going to be our most dense. And because our Diet Coke floated, it's going to be our least dense. And the water is going to be in between those two. So our regular Coke is more dense than water because it sank to the bottom. And our Diet Coke is going to be less dense than water because it floated to the top. So water is going to have a middle density, which we see right here.